So we're going to talk about MySQL security, more than just ACL. So ACL is an access control list, which is probably my first slide. It's not, which is just the user table in MySQL. So if you think about security, you can think like, wow, there's a lot you can do with the access control list just with grants, but you can do more. So in general, when you're talking about security, you want to talk about patching. You want to talk about making sure you're up to date so that you aren't vulnerable to any of the things that are out there. Because if you're using older versions of software, whether it's Apache or MySQL or anything, then you can be vulnerable to problems. So in general, you want to think about security, things like patching, but also preventing access to MySQL. Who's allowed to access it? Whether you're talking about accessing through the network or on the machine itself. And then you can talk about who can access it, but can they get meaningful information? Nobody ever says, hey, we lost this database that was just a join table, because it doesn't really matter. It's just a bunch of numbers. There's no information there. But you start to lose social security numbers or email addresses and all that kind of stuff, and it gets pretty hairy. Right now, actually, the European Union has some really strict guidelines on security, even with email addresses. And so there's some pretty tricky stuff if you're dealing with anyone who lives in the European Union and their email address. There are some pretty strict guidelines you have to actually adhere to. And so the US doesn't adhere to them, but we have something called Safe Harbor. So you can be Safe Harbor certified, which just basically means even though we're not in Europe, we're like a safe harbor for great in Europe. Safe Harbor is actually a self-policing thing, so we'll see how well that works, but that's just for you to know. So let's talk about access. What kind of access can you have? You can have network access. So what's going across the network? If you're on Amazon AWS, for example, and you're just going from a web server to a database server, everybody else who's on Amazon AWS can sniff that traffic because it's not a private network. This used to be like, oh, just put it behind a private network. Now with the cloud, it's opening things up, but it's opening a lot up. And who here uses replication? I know I do. Who here uses SSL with their replication? Okay, one person. That's one more than I expected. Most people don't use SSL with replication. I've used it in the past. I haven't found that it's like degrades performance or anything like that. And that's a little easy thing that you can do to protect your data from being seen across the network because it will be encrypted, SSL encrypted. So who can directly access the database? Obviously your applications can, but can your developers, can all of them access your production database? You might want one or two just in case something happens and they need to do something, but probably they need to debug or something. But probably you don't want everybody to have access to the database. And also access to your backups, because your backups are all of your information. So it doesn't matter if your production system is locked down and your network access is locked down, if your backup server isn't and they take your backups, they can literally just copy the files to their system and use them. That's one of the great things.
By backups, you mean data backups or server backup executable as well? So
the question was, do I mean data backups or server backups? And I mean both. If they can get that, it's the backup of the data. So if you're backing up your data with a MySQL dump or copying the files or using extra backup, those files, but also if you back up the server with all the data on it, that too.
You have to build a cloud image that you stop every night to take a snapshot.
Exactly.
Where are they putting that snapshot?
Yep. So with network and seeing traffic, I actually probably need to update this since Forge is dead. So sad. MySQL Forge is dead. So who can log in on network and seeing traffic? You can actually use TCP dump. If you have root on the machine, any machine, you can run TCP dump and actually sniff for MySQL traffic, and you can see all that traffic that's going by. You can sniff specifically for port 3306 or for anything. So again, if you talk about something like being in the cloud, you might say, well, it doesn't matter, they don't have root on my system, but they might have root on a system anywhere on your network. And that's all you need. And so, if you have private networks, it's not a problem, except for maybe, internal threats. But if you have anything that's public, it can be a problem. And by nature, most people's businesses is somewhat public, right? You don't just have a database that lives in your system, in-house with nobody being able to touch it. You may have some databases like that. Your monitoring database, for example, isn't hopefully not open to the world. but most of the time, there's some kind of external public access to your database, whether it's through a web application, through an app server or something like that. So there is some kind of, somewhere there is some public, being able to touch something that it eventually touches your database. Who can log into your operating system, right? This is obviously a smaller amount of people. It's not the general public, hopefully. What can they see? They could see data files, they could see logs, they could see backups, because your log files, the binary log, has all of the data of all the changes in it. So they might not be able to see all the data, but they see all the data that's being changed. And again, when you're talking about email addresses and social security numbers or government ID numbers, you really don't want any of that to get out, even if it's only just the changes. So this is actually, I'll put this on the slide before. When I said you can use TCP dump, this is actually the string you can use to see what happens there. So I'll actually just copy that to the last slide. This was, we used to be called the poor man's query profiler, back when it was on the forge. Put it in the right place. So, and I had that on this slide because you can actually see it's unencrypted. When you connect to MySQL, it's not encrypted. They can see, now your password is encrypted when you send it to MySQL, but that's the only thing. So if you send a select statement, an insert statement, an update, it's all unencrypted, and you can just see it if you're on the network with TCP dump. And the interesting thing about MySQL is that when you do this SSL, it's per client. Specifically, it's per user. You can't just say, MySQL don't allow connections that aren't SSL. Like with HTTP, you can do that. You can say only on port 443 and only if they've actually got encryption going on. You can't actually do that with MySQL. What you can do is you can define your users to only allow SSL. Now, there are some users you might not want to define as SSL if your application can't handle it, or the root user on localhost. You probably don't want to define that as SSL only because if you're having a problem, and maybe you're having a problem with certificates, you don't want to end up being locked out of your system. Because if that happens, you would actually have to shut down MySQL, restart it with grants skipped, and have to actually redo your grants. So, on the operating system, I won't talk too much about this because it's important, but you can find volumes on system administration and security of systems. But you want to think about who can authenticate. Think about your firewalls. Who should be allowed to see your MySQL port? Should you even open the port up at all? Maybe you have a web server and a MySQL on the same box so that it's faster or something. A low traffic box, then you don't even need it open on TCP ports. But if you do, who should it be open to? Your load balancer, your application, maybe your VPN. But do you really need it open to the world? I mean, unless you're running a service where you allow people to connect directly to your database, you pretty much never need to open your database to the world. And what else is on that system, right? If you do end up having MySQL on the same system as your web server, your app server, your web or app server is probably open to the world, right? You want the world to come and see your product. But what happens when your app gets hacked? And they can, they hack your web server and they can get to your database because it's on the same machine. So it's something to think about. The other thing is you can accidentally denial of service yourself, which isn't really a security issue, right? It's more of a performance thing, but when you say, hey, why can't anything connect to the database, and you can't connect, you start to think about denial of service attacks. If you end up doing too much on one machine and MySQL starts to crash because it can't allocate the memory it needs to, you can have problems. So these are all things to think about. There's no one right answer or solution. It's what your system looks like overall, the architecture of it. So on the operating system, files and permissions. So MySQL runs as the MySQL user. It does not run as nobody or anything like that. So it doesn't run as root. You don't want it to run as root. And if you try to run it as root, MySQL will actually complain and be like, you're not running this right. MySQL server files and logs, those are actually pretty secure by default. It's usually only the user MySQL, the group MySQL, readable and writable. If you're typing on the command line and you type, MySQL-u Sheeri-password, that's actually okay to do, It will get stored in your history file. So if you're using bash, it's in your bash history file.
Also the PS.
And it's, well, no, it's not in the PS. If you do, it hasn't been for a long time. It used to be in the PS in like 3.23. But ever since like 4.0 or 4.1, if you do, so his question was, isn't it in the PS list? And actually, if you do that, if you do a PS and you look at it, you'll actually see MySQL-U Sheeri-PXXX. It puts little X's in. And it's not even, I think it's 5 X's, and it's always 5 X's, even if your password is 20 characters or 2 characters or empty. So that's pretty good that MySQL does that. But it is stored in your bash history file, so you want to be careful about where you put it. And you know, the last one is office policies in your runbook. What are your policies? What is going to happen when you hire someone? Where do they look for the passwords? You know, if it's just something that you know what the root passwords are, what happens when you leave the company? What happens if you get hit by a bus? You know, something. There's got to be some kind of policies of what kinds of passwords you use, where they're stored, and what kind of how do you access it? Do you store things into MySQL Workbench? You know, how does that save it? I know that MySQL Workbench used to save passwords in a plain text XML file. I don't know if they still do that, but now you've got something that's on your computer, your desktop, or your laptop, right? That might have something in plain text with your passwords to your sensitive systems. You know, your laptop might not be as heavily locked down as other things. So you have to think of the whole flow of everything and how it goes. So how do you secure your application? You have to think about who is allowed to authenticate your application, if you have authentication, and what they can do. Can they just type in stuff? Can they just type in a query into a text box, right? Are you PHP-MyAdmin? You know, which has to allow, right? They designed it to allow arbitrary data to go, arbitrary queries of data. You know, most people aren't running that kind of service, so what kinds of things are you doing? You have to be careful about user-entered data and SQL injection. We'll talk a little bit more about SQL injection in a bit. Your configuration files. It used to be that people would put the replication information in the configuration file, etc.my.cnf or my.ini if you're on Windows. That's been deprecated, but for obvious reasons, right? If your password is in plain text in this configuration file, it can be a bad thing. You can also get certain information from configuration files. For example, I can actually, I can see how many max connections you have. Sure. And if I really wanted to be, you know, a pain, I could start, you know, making TCP connections, leaving them open. I know exactly how many I need now. This is obviously more of an internal threat kind of thing, but you do have to be careful about your configuration files. And configuration files for your application. The application needs to connect to the database. So the application needs to have the authentication information, and usually it needs to be in plain text because your PHP or your Java or your Ruby, well, nobody's using Java anymore, right? Even the Department of Homeland Security just came out with something that said don't use Java. Which is funny because when I'm like, oh, the government's telling me not to use Java, now I'm like, now I want to use Java. No, wait. Did everyone see that? The Department of Homeland Security recommended not to use Java. Yeah. So, because of the security hole that was recently discovered.
Predicting 2 years to patch it.
And
Properly patch it.
it took them 2 years to patch it, or will?
Oracle's released a preliminary patch, but they're predicting it's going to take 2 years.
Predicting it's going to take 2 years to, wow.
For everything.
Oh, so just stop using Java. If you
Right, all those Java
They'll be all right.
developers, what are they going to do? Yikes. I know I turned it off in my browser, so.
Oh, JavaScript.
No, Java.
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 Server side.
Server side, don't use server side Java.
Right.
Yep.
Yes, there's evidently this.
There are exploitable holes.
Some severe problems.
Yeah.
I do not know what they are.
And the whole plan is just scared to death. I mean, I've got more Java programs in C# Gee.
Right. Well, I figured it was better safe than sorry. Let me turn off Java in my browser and see what doesn't work, and then decide whether or not I want to turn it back on. But you know, because you never know, things that used to require it 5 years ago, you might say, oh, this application required it, but maybe they've changed. You know, maybe they're using Flash now or something, because that's it. So anyway, nothing secure though. So how can you see who has access? Now I said this was beyond ACLs, but I'm going to talk a little bit about the access controls you have. How can you see who has access? Well, the Percona toolkit is really awesome. It has this tool called PT Show Grants. And by default, what it will do is it will show you all of the grants for all of the users. Which is actually neat, because MySQL doesn't really give you that capability. What MySQL gives you the capability is you can see all of the tables. So you can say, select user host from MySQL user, where user equals Sheeri. And then you're like, oh, okay, so it's Sheeri at localhost. So then you can say, show grants for Sheeri at localhost. When you have 200 users or something like that, which I was just on a system earlier today that has 216 users, and I was upgrading, so I wanted to make sure that I had the grant statements, just because you never know. To upgrade, I was copying from another server that had already upgraded, so I didn't want to just copy the whole thing because maybe there was some permissions that the other server didn't have. So I did that, because otherwise I would have had to run a show grants for 216 times. So the way that you can do it, as I said, is you can do stuff like select user host password SSL type from mysql.user. So you can just do this one command, and it will show you everything. It will show you every user, the username, which is user, host, and the password. Now the password is not in clear text, it is encrypted. If you're using old passwords, it will be encrypted with a 16-character kind of a hash. I think it's 40 or 41 characters with the good password hashing, and if it's with the long one, the good one, it starts with an asterisk. So one thing I actually do, if I'm like when I first did the upgrade, what I wanted to do is I took a slave and I did a MySQL dump and I imported it. But I wanted to make sure nothing was going to happen, nobody was going to connect to it. So what I did is I actually just reversed the passwords. So I did a update MySQL.user set password equal to reverse password where user does not equal root. And it's really easy to see what's going on, because if you look and everything ends with an asterisk instead of beginning with an asterisk, you know that you're like me and forgot to put it back to normal when you finished your upgrade. You can also say where superpriv equals y. There's a lot of reasons that superprivilege is great. It lets you do everything. The problem is it lets you do things like shut down MySQL. It also lets you see everybody, control everything, right? You can change users, update users. If you hit max connections, so max connections by default is I think 150 or 151 at this point. I think it's 151, because I think Apache's default is 150. So they wanted one more than the default Apache. But let's say you hit max connections. You actually have max connections +1, and that +1 is for debugging. And that is given to somebody with a super privilege. So MySQL does start with a user called root, but that's not a special user. You can drop that user if you want. You can make a user called Sheeri that has a super privilege, and it's just the same as having root. It's not like a Unix system administration box it's not like a Unix server where root is actually like a special name. So if you want to see who has the super privilege, you would add on where superpriv equals y. You also, instead of saying this, you can say where user equals blank. Now MySQL usually does start with empty databases, but it does have a couple of users. It has root at localhost, root at the IP address, and root at the host name. And it also has the blank user, which is called the anonymous user. And if you look and you do a show grants, it'll say, oh, you grant usage on blank at localhost. And you might think, okay, it's just usage. It can log in. Who cares? Well, so the first thing to note is that the anonymous user is not just a username of blank. It's a username of anything. And the second thing to note is that it's not that they can't do anything. They can actually do anything to the test database or any database that begins with test underscore. Which is really, really interesting when you start to get into a bunch of developers who are working on different things and you give them one development system and they're all sharing things and they're like, hey, wait, I'm from the Mozilla support team. I can see the test underscore support, but I can also see the test underscore add-ons. How come I can see the add-on stuff and add-ons can see support stuff? Well, it's because the database starts with test underscore and everyone can see it. And not just see it, they can add to it. They can delete from it. They can drop the tables. They can do everything. So it's the database called test and any database starting with test underscore. Now, if you think about just like a random system, you're like, well, whatever, it's a stupid system, who cares? I'll leave the test database on it. I'll leave that user on, the anonymous user on it. Well, anyone who can do that could say, stuff lots of data, make a table, put tons of data in it, and then fill up the disk on that machine. And when the disk gets full, MySQL is not happy. It just waits and waits, because you can't do anything, because you can't commit it to a log or do anything. So, you know, it just waits and waits and waits. And it will happily wait. And, you know, at some point you can't connect to it anymore. And, you know, people don't know what's going on. They don't know, you know, somebody's in the middle of the import and they're like, I don't know, it's just waiting and waiting. Why is it taking 5 hours to do a 10 megabyte import? You know, and the answer is because you're out of disk space. So there are, you know, it's the consequences of these things are, you know, are difficult sometimes. And, you know, you may say, well, who cares if they drop a table from the test database? You might not care. But if they fill up the entire database and you can no longer use that machine, that's a problem. So where's the access from? So this is what your host column might look like if you said user, you know, select user host. Percent is the wildcard character, multi-wildcard character in MySQL. Underscore is a one character wildcard. So if the access is from percent, it means allowed from anywhere. If the access is from percent.company.com, it's any machine with a host name of that. Now, host names can be spoofed, but it, you know, at least it's a little better. They have to do a little more work, right? So I like to talk about security as like when you go to a big parking lot and you park your car there, right? Who's going to steal your car? Now, if you are like me and you have a Toyota, nobody really wants to like steal your car. It's not a sexy car, right? It's not like a convertible, you know, that's not it. So that's most companies. Most companies are not, you know, a bank, the Department of Defense, you know, the government, like that's like a sexy target. That's a Porsche, right? That's something that people want to steal. You know, whereas me with my Toyota, that's more like, well, they're not going to steal it, but if I leave the doors unlocked and I leave like a CD on the thing, or actually when my car did get broken into a couple of years ago, it was just around Christmas time, and I was going to bring a VCR to somebody the next day, and I left the VCR in my back seat, but I left it so that the back of it was facing out. So basically, they smashed the window of the car. I left it locked. They smashed the window of the car and grabbed this black box. They probably thought they were getting an Xbox or something. They didn't know, right? It's just this black box with connectors at the back, and they grabbed it. They didn't even grab the remote, which made it useless. They probably threw it away, you know, a block later, but, you know, I still had to deal with my broken window. So there are things that you can do to kind of lock your doors and secure your windows in the database world. And so, you know, doing stuff like allowing from percent.company.com. If you're on Amazon AWS, I think you might have to do like 10.0% or 10.%, because you have to allow a lot. But it's still better than allowing from everyone. You know, allowing from everyone in the 10.% is still better. Or 192.168%, that's your local kind of network. That's still better than allowing it from everywhere. So that's something to think about. MySQL actually does something very, very interesting too. We have a lot of like network flows and firewalls. So at Mozilla, everything is off, and you have to specifically request from network operations to open net flows. And so what I ran into when I was first working there was I would do like a telnet to see if the port was open, right? And telnet, whatever, 3306. And you know, if I got connection refused, then I'd be like, oh, I need a net flow. And one day, the guys were like, the net flow's open. And I'm like, no, it's not. See, look, telnet. And they were like, oh no, here, look at this netcat, nc-vz, you know, the host name in 3306, and it was connected. Now, so I was like, but why doesn't telnet work? And the reason that telnet wasn't working is that MySQL was configured to only allow from certain hosts. It wasn't configured to allow from the host I was coming from. So the TCP connection was successful to MySQL, and MySQL rejected the TCP connection because it said, there's nobody from this host that's allowed. So you're not allowed. I know you're not allowed. There's not even a question in my mind that you're not allowed because there's no access there. Which when I ran across it was awesome. Because you know, I'd already been working in the field for 10 years and I'd never seen this because there's always at least one user, right, that has percent or percent.company.com. You know, there's always like one user that has that. So it was interesting to run across that. And actually, we just hired out a DBA, and I was telling him about this, and he was like, I need to test that out. Because that's incredible. I don't believe that. And I was like, it's true. It's true. So this is a grant statement. There's a lot of stuff here. I will go over it quickly. But you can actually go to the manual and see the grant statement. So the reason that I wanted to put this out here is that there's actually a lot you can do. People think MySQL security, and they're like, whatever, there's not much you can do. But there is a lot you can do. So a lot of times, you know, we know grant privilege types. So grant select, grant all, grant update, grant, you know, trigger. But you actually can specify a list of columns. So you can actually show, you know, grant select on certain columns. So, you know, you just have a list of columns.
This is new in 5.5.
I don't think this is new in 5.5.
And this is across all MySQL or just certain databases enforce it?
Across MySQL, it's the ACLs. So let's do this and go to 5.1. Yeah, 5.1 had the column list. So you can say grant select on this column and delete on that column.
But could you join? So you can't see it, but can you use it within your where clause for your join if for some reason you wanted to hide?
That's a good question. So the question is, if you don't have the privilege, can you? No, because you can't access it. MySQL won't let you access it. So if you have it in your where clause, even if you're not selecting it, right? Because I mean, why would you want to do that, right? If you're saying select table name where from information schema.tables, where table schema equals, right? MySQL. You don't care. You're not selecting the table schema. You already know what it is.
Yeah.
Because you're filtering on it. But no, you wouldn't be able to see it if you didn't have permissions to see all the columns. You wouldn't be able to join them.
So the grant you'll get a when you try to run the query, it will say something very clearly like you can't join because you don't have access to this column.
Yeah, it'll say something like permission denied.
Okay.
I don't think it's very specific. I don't think it'll
Not
say,
just-
oh, you
not
can't
just
do it
failed.
because you don't have access to this column.
Or just zero response. Yeah, 0 rows. Like.
No, it wouldn't do 0 rows returned. You'd get an error. So you can actually do it per column. So instead of maybe setting up a view, you could not have that overhead of setting up a view. You could just say, okay, they have access to the table, but not the whole table, just certain columns of the table. Of course, if you do that, you have to be careful because you have to make sure that you, when you add a column, if you want people to see it, then you have to keep updating it. But we actually have that in Mozilla. We have. We do allow, we have a big Bugzilla, which we make, but we also have a big installation for us to use. And there are some bugs that are not for public consumption. They're legal bugs, for example, or confidential bugs, like if we have a security breach, we'll make a bug for it. It's all in Bugzilla, but it's not necessarily something where we're like, oh, this password was breached. We're not going to make that bug a public bug. But we have metrics, folks who want to do some metrics on them. So what we do is we give them, like, in the bugs table, every so often, I have to go and add some grants. Every time there's a new custom field, and there's a new custom field every time we do a new release. So, like every month or so, I have to put in a new grants for the metrics users. And it's not that difficult. So on object type, so it's an event or a table name or database name. So you have table names. Even though the wildcard character for SQL is % and underscore, MySQL uses star in the grants because. Hey, why not? So you can actually say on star.star, on dbname.star, you can say on star, on dbname.routine name. So there's a whole lot of different access controls you can give here. To a user, which is user at host. So when we say user, it's a user at a host, identified by a certain password. Now the interesting thing is you can actually have two user names that are the same with different hosts and different passwords and different grants. I wouldn't recommend doing that, but there are times where that's happened, for bizarre reasons, like importing grants from some other database that had that same username with a different password, different grants. You can run into trouble when doing that, so I wouldn't advise that. But it works, and if you come from that one host, you need that password. If you come from this host, you need this password. And then this bottom part is all pretty much, almost all of it is SSL options. So there's require none. And that means, and that's the default, which is don't require SSL. There's also, so when it says require none, that means SSL isn't required. You can still use it, it's optional. So just because all of your users don't require SSL doesn't mean you're not secure. You could, if all of your users are connecting by SSL, then you are secure. But you can actually say, hey, this user should require SSL. And that just means any certificate, any encryption is okay. It could be expired, it doesn't matter. As long as it's encrypted, I don't care. And then you can also actually say it has to be an X509 certificate, so the type of certificate. You can say it has to have a certain cipher. It has to be a certain certificate authority, the issuer. So you can actually get pretty specific with the different kinds of SSL you're allowing, right? Most of the time, you'll just say, I don't care. As long as it's encrypted, you can connect, because that's really what you care about is someone sniffing on your network. But if you're worried about things like, man-in-the-middle attacks or something, you might say, hey, it's got to be by a certificate issued by my company. And then you've got subject, which is just kind of a comment, from what I understand. And then with options, so with grant option. There's actually a couple of more options that didn't fit on this page that I'll talk about a little later. It's restrictions you can give them, some grant limits. So other ACLs, you can have object access, right? So you can have events, triggers, routines, a password policy. So again, we were talking about policies before. What do you have in place? When do you change your passwords? Do you change your database password when a DBA leaves? Probably not, right? Because you worry, like, what about when a developer leaves? A developer who's been working with the application and might have had access to the files, have the password. Do you change that password? Should you? You know? I mean, you might say, well, it's not really feasible, whatever, but you better write that down somewhere in a manual, right? Because if something happens and your boss comes to you and says, well, obviously, why didn't you change it when this person left? Why wouldn't you change it? Like, when a system administrator changes, we change all of our root passwords. Why wouldn't you change your password when a developer left that might have access to it? So if you write it down and they agree to it, at least you know that it was, that you're following policy. Even though it may not be, right? There's following policy and there's being secure, which is kind of like the difference between, being secure and being compliant. Just because you're compliant doesn't mean that you're actually following everything. It just means that people have agreed that you are. And then there's roles. So MySQL doesn't actually have roles like, hey, here's a DBA and DBA has access to update everything, and here's a developer and they have access to select everything. It does, you can use a role account, like let's say you call it DBA, or your application has a role account. For people accounts, you have to figure out, again, here's your policy. Do the DBAs all connect as DBA? Do the developers, when they're testing things, all connect as the application user? Or do they have their own users? There are programs out there that do have roles. Securich has roles. So Securich is it's a community, it's a third-party tool like the Procurement Toolkit kind of stuff. It's written by Darren Kasser, and it actually has roles. So you can say, hey, make a DBA role. And then what you can do is you can instantiate and say, Sheeri is a DBA, so give her all the DBA stuff. So it makes that stuff a little easier. It's all done with stored routines and objects in the database. So it's fully within the database, it gets backed up with the database, and it's good stuff. So we were talking a little bit about access before, but you can actually access only from localhost with skip networking. So what happens there is that you only connect on the socket, not on TCP. So TCP, there's no networking at all. It's just through sockets. That's on Unix. On Windows, you can use either shared pipes, or is it named memory, I think it's called. There's two different ways to be local only without TCP. And firewalls, again, where can you access it from? And when you're thinking about this, you're like, well, everyone should be able to do whatever. Well, think about it instead of where should people be allowed to access it from. Think about who can denial of service attack you or attempt to denial of service attack you. Because MySQL, well, Linux by default, right? MySQL has max connections. But Linux by default also has a max TCP connections. It's about 10,240. And I know this because I was testing MySQL, doing some load testing, and we were trying to test MySQL cluster to see if it would be great for this big application that had a lot of very small data. It was queuing. It was actually for CBS Sportsline back in, I think, 2007 or something, when they did their first Watch the Games online for March Madness. They were like, we're going to have like 1 million people on this. We need this to not fall apart. We need to, so we were load testing it, and it would only accept about 10,000 connections. And we're like, well, I guess we can't use MySQL cluster. I guess we'll try memory tables. And memory tables had the same problem. We realized it was a Linux TCP kernel problem. And 10,000 connections, I mean, I'm not really a security person, and I could probably find a program, right, that will do 10,000 connections. Sysbench will do it. But I could, probably find some kind of bot that will do remote with somebody else's server. So if you have one machine, right, you're only going to get about 10,000 connections. So who can attempt to give you denial of service, to attack you? That's really how you need to think, not just like who should have the access. You should think who shouldn't have the access. I already talked about this. Test database, anyone can access it. Stuff with data, and anything that starts with test is going to have that problem. So I was talking about, when we talked about grant statements, I was mentioning that there are some other things. You can actually say that a certain user can only have a certain number of connections per hour or a certain number of queries per hour. or a certain number of updates per hour. And by updates, they mean writes. It's not just the update statement. It's insert, update, delete, replace. Replace actually would count as 2 if it actually deleted and inserted. So you can actually specify how many. Now it actually seems pretty cool. And I think it is pretty cool that they have that. But you only have queries per hour, updates per hour, connections per hour, nothing else. And it's only per hour. You can't say like per day or per minute or per second. You know, those are kind of the limits that you might want to put on it. Like, can you even imagine, you know, maybe more than 100 per second from the same user, unless it's the application user. I probably don't want like more than 10 per second on the root connection, for example. But per hour, you know, I can't even, like, how many connections per hour would I want the root user to have? I don't know. If I'm debugging a problem, I want it to have a lot. I don't want to run into problems there where I've given myself, well, I shouldn't need to get more than 5 times in 1 hour, and then when I'm debugging a problem and exiting and coming in, then I have a problem. You can also say skip symbolic links. So by default, MySQL will follow symbolic links. This is actually a server parameter. And so what that means is if you really want, you can move a file and put a symbolic link to it. I've used that trick when I'm running out of disk space and I haven't quite gotten the new disks yet. You can actually move any file, any directory, you know, move the .ibd file, move the MySQL directory, and put a symlink to it. So if you're worried about someone doing that maliciously, right now they would have to be on the machine to do it. So it's one of these kind of like, well, if they're on the machine already, maybe the game's kind of over already. But especially if they can move, if they can touch a MySQL file and move it aside, that's, you know, they probably have enough access to do damage anyway. But if you're worried, you can skip symbolic links. And then another server parameter is called local infile equals 0. Now, what does this do? This is if you're doing a load data in file, you can actually specify that it has to be on the server. So this says it has to be on the server. Local means local to the client, right? So if I'm coming from my machine and I'm loading a file, if I can load a file from my machine, that's less secure than if I have the permission to get it to the server, right? So to me, it seems a little backwards. It seems like, well, it's less secure if it has to be on the server, right? But the idea is if you've gone through the hoops to get it to the server, then, you know, again, if you can get it to the server, it's probably game over anyway, right? If they want to do something malicious. So it's kind of an interesting little thing if you're worried about people importing malicious data, or even importing data that doesn't mean to be malicious, but just has semicolons in the right place and does some weird things. So, changing ACLs. Again, this is on policy. Who changes them? How are those changes audited? You might say, well, our DBA does it. Well, but who's watching the DBA, right? Making sure that they're not making backdoors or, you know, changing things around. I mean, when I worked at one company, our director of IT left. And after he left, some of the marketing guys came up to me and they were like, well, can we get more users for this application? And I'm like, sure, it's just HT access. And they were like, oh, the old director of IT told us we could have 10 Macs on it. I'm like, it's HT access, I could put 1 million people in there. You know? So who was watching that policy that was being made? Nobody. And then that's HTTPS, it's not MySQL, but you could easily imagine a scenario where somebody's saying, well, I can't do that, you know, who's doing it? You know, when I get a request for access, I have to look and see what kind of data is there. Again, we have to be safe harbor compliant, so if there are email addresses involved, you know, it can be problematic. I actually had to go through about a month of talks with the security folks when they were changing their policies on how to do this with all the safe harbor and everything. Because someone who runs the Mozilla community wanted an updated list of email addresses for the people who had signed up for the email list. And they were like, can I just get a report? And like prior to that whole, you know, the safe harbor stuff, I would just run a report, right? Just export, just select email from table, you know, where whatever, and go, and just mail it to them. But because, you know, we have to worry about that stuff now, because everything has to be, you know, by the book, you know, it wasn't, I mean, it was still a simple export once I got the permissions, but you have to make sure that it's not just, the problem isn't just the how do I get the emails from the database, it's how do I make sure I'm compliant with everything. So, you know, who's checking that? Who's checking to make sure that that's happening? You know, I could have just run the export and given it to them. They wouldn't have known. I mean, but, you know, I would have gotten in trouble eventually if somebody did find out. So how are those changes audited? Do you know when changes are made to these access controls? Maybe there's a developer that's just giving themselves a user every now and then because they need to see it. And when do they happen? Again, when a developer leaves, when a DBA leaves, when a system administrator leaves, who can access this stuff? how long has it been since you changed it? Maybe you just have a policy that you change it every 2 years, or every year, just because. I talked a little bit about Security before, but here's the URL if you can see it. You can create and drop roles. So the way that roles are done is that a role is just a series of permissions. So here I'm going to add role 1. In fact, I won't call it role 1. I'll call it read role, because that would be a better name for it. And so here I'm creating a read role, and I'm adding it, and I'm giving it the permissions of select. And then what you do is when you instantiate the role, you tell it what you want to do. So you can call grant privileges on username, hostname, database name, table name, table type, role name, and email. So for example, I want to grant reading to john@machine.domain.com on the employee's database name, all the tables, right, and blank, the table name is blank, that means everything. So this is giving john@machine.domain.com read on all of the tables in the employee's database. Security has a reserved username, so you can say nobody can have the username God or something if you don't want. You can block users. Now in MySQL, you can't block users. You can drop the user and that's it. With Security, what you can do is you can say, just disable this user.
Actually, a way to block a user is you add a character to the encrypted password hash, and that will be equivalent to blocking,
Right, so
which is what Linux does, but with a command line option.
Right. So Jerry was just saying you can block a user by putting an extra character in their thing, or like I was saying before, I did a reverse in the password hash. You can do that. It doesn't, technically it doesn't block the user, right? The user would still be allowed with this invalid, if they could ever get that hash to work, they could connect to it. So if you just want it to not show up in the user table because it's blocked, then you can actually do that with Security. You can rename users easily. In MySQL, you can rename a user because you can update the table, but in many cases that actually resets the permissions. And that's actually happened to me with host names for sure, because we would move data centers. And I was like, oh, well now the load balancer is this IP address, now it's this IP address. And so I changed it, and they were like, I still can't connect. And I'm like, yes, you can. I changed it, and they were like, no. And then I looked at the permissions, and the permissions were reset to like nothing. And I was like, oh, that's not good. Luckily, I had done a PT show grants before I changed anything. So always back up before you change anything. So yeah, rename users, you can clone users, and you can do reconciliation. So what's reconciliation? Well, I said before that Security is a bunch of like stored procedures and routines and stuff like that in the MySQL directory, MySQL database. And so what happens when you say block a user is that it gets dropped, it gets deleted from the MySQL.user table and put in a Security table. And so if you do something like add a user through Security, well, Security knows about it. But if you just go and grant permission, Security doesn't know about it. So reconciliation is reconciling the Security tables with the MySQL tables. So again, if you have the policy of you will use Security and that's how you're going to do stuff, then you're going to want to reconcile every now and then to make sure that, in fact, Security knows about everything. More server options. We talked about local in file and we talked about skip networking, but some more are bind address. So by default, when you have MySQL listening on, say, port 3006, which is the default, it listens on all of the interfaces. So if you have 10 different network cards, right, it will listen on, and 10 different IP addresses, it will listen on all 10 of those. If you want to be a little more secure, maybe you're in a virtual machine or something, you want to bind the address to one of the IPs, you can actually do that. Or you can bind it to 5 of the 10 IPs. It's not just, you can bind it to 1 or more of the IPs. You can also do skip name resolve, and that's somewhat of a security feature. So if you've ever logged onto the database, MySQL does a 5-part handshake. As you know, MySQL will reject a connection from something that where the host is not anywhere, cannot be in the access control list. But there's actually a 5-part handshake that goes back and forth. And one of the things that you might see if, say, you're doing name resolution from a host name is if DNS is really slow, you might log into MySQL, do a show processes, and you'll see a lot of things with a username called unauthenticated user. Which the first time I saw it scared the pants off of me. Because I was like, oh, what do you mean unauthenticated user? Why do I have unauthenticated users in my database? That's not good at all. But what happens there is it's just not authenticated yet, right? It's pre-authenticated, right? They're not doing a query. They're still in the authentication thing. And the reason that you might see them, especially when DNS is slow, is that if DNS is slow, it's not resolving the name, or DNS is broken, it's not resolving the name. And so what ends up happening is there's a timeout, but you have to wait for that timeout to happen. Things get cut off, you end up with max connections, and it all goes horribly. So this is another one of these kinds of features that you can use, that if there's some problem and somebody takes down your DNS, you're not going to have a problem with this. You can also do skip show database. Skip show database will not allow people to do show databases and see like the test database, things like that. I mean, they still won't see things they don't have permission to. So how does your data flow? Where is data encrypted if you encrypt it? What are you encrypting? Are you encrypting credit cards? Are you storing them at all? Do you need to store credit cards? If you're just storing like, hey, this person purchased something, do you need to store their credit card, or do you just need to store like a hash of it with the last 4 digits so that you can get it back to them? If you're doing something like a monthly recurring payment, you probably need to be able to see what the credit card number is, because you basically have to get the credit card number and send it again every month or whatever it is. But if it's just a one-time purchase, is there even a need to store the whole credit card somewhere, even hashed? If you're doing recurring payments, I would, obviously strongly recommend to have some kind of password hashing, and obviously you need to be able to decrypt it, so you want salts and whatever. But don't just kind of think, how can I store this securely? Think, do I need to store it at all? Do you really need to store an order that somebody made with a credit card 5 years ago? Amazon doesn't store your credit card from 5 years ago. They might have your credit card on file now, but they shouldn't store your old credit cards. There's no point. Where do errors go? And are those error logs checked? You'd be surprised at how many people don't check their error logs, but that's important. And it's not just for MySQL. It is for MySQL, but not just for that. And if you see, if you see problems, that can be an indication that there's something that's vulnerable. But it's also your application logs. I know a lot of developers are like, oh yeah, I will look at them and be like, nobody's written to this database for a month, and they're like, oh, our application was having problems. Like, nobody noticed for a month that this application wasn't working? And where does the traffic flow? So again, over what networks? Draw it out and be like, okay, the data's here, and then we back up here, and then we copy it here offsite. Every single one of those pipes in between your machines is exposing the data. So is it done securely? You might say, hey, we stream backups. Well, that's great. Can you stream it over? Are you streaming it over Netcat, which is unencrypted, which is a lot faster, right? But unencrypted, or are you streaming it over SSH? And if you're streaming it over Netcat, are you doing it on a private network? It's probably okay. Again, policies here. Is your policy that you can stream it locally over Netcat, but if you're on Amazon AWS, right, you might want to use SSH. Separating administration apps. So this can be for security, it can also be for performance. Let's say you have a reporting, or you have some kind of administration app. When I was working at a dating site, they had in-house customer service, and they had a whole admin interface where the administrators would log in, and they would be able to get, to see profiles and change things, and mark people as paid, or give them, memberships, or whatever it is. So, obviously if somebody broke into the web server and was able to connect to the database with those credentials, it's a problem. So what we ended up doing is actually having a separate set of web servers for the administrative interface. So we had like 10 web servers for the site, and then another 1 web server just for the administrative interface. And that actually gave us a lot of benefits that we didn't think about. Like, we didn't intend to have it. We ended up getting the benefit. For example, when we did a major site upgrade, we would shut off the web servers, including the administration server. We'd do the upgrade, and we'd turn on the administration server. So people, like users, couldn't log in, but our administrative people could log in, and they still could see most of the site. So if there was a problem that affected, something really blatant, like, hey, none of the web pages work anymore, or now they're all hot pink instead of blue, that could be spotted by turning on the administration app, right? And we still didn't disappoint users. So that was kind of interesting. It's also good for performance. So if you actually have like a separate reporting database, for example, you're running reports, you can run them on a separate database that customers don't see. Again, at the same dating site, whenever we would run a special, one of the founders of the company would keep running the financial reports to be like, wow, how many people have we got now? How much money's going to my bank account? How much money have we gotten? And he would actually bring the site to a halt by running these reporting things, because it was doing these reports by state and by country, and we were in like 37 countries. I mean, there was a lot of stuff that it was doing, and you know, every single state, and he would just like refresh it, you know, and it would be like 8 p.m. and it's dating site, so 8 p.m. was like peak time, and you know, we actually had to, we tried telling him like, hey, don't run these reports, but that didn't work. So what we ended up doing is, it was a PHP script, and I was like, okay, if it is between 6 p.m. and 6 a.m., don't run the script. Like, that was the very first line. It was like, question mark PHP, you know, what's the time? If it's after 6 p.m. or before 6 a.m., say, sorry, you can't run the script right now. And otherwise, do the actual thing. And, you know, he got the message, but, you know, it helped a lot when we did finally move to a reporting server. It helps a lot, and he actually never complained. I think because we had told him he's not allowed to run the reports, and then he was allowed to run them for another like month or so until we put this little thing in. So now, if you have an administration app, our administration app was actually allowed from anywhere. It was on HTTPS, so the connections were authenticated, were encrypted. But we did have a question of, should it be open to the public or should it be open to VPN? And we decided that we had a lot of people traveling. They were doing a lot of, you know, parties because it's a dating site, so they're, you know, getting a lot of things like that. And they didn't know when they would be in a hotel or an airport that wouldn't allow you to connect through the VPN. But that's something to think about. Is you can say, well, we have this administration app. We don't want someone to break into it. So maybe it's only allowed to be on when you're on the VPN. Maybe that's the only thing that can connect to it. So this probably goes without saying, but you know, I should put it in here because hey. You know, it's data. We have data in our database. And if you're storing stuff in plain text that is sensitive, it's not a good idea, right? Passwords, credit card information, identification numbers, don't do it. I don't often say don't do X ever, but I will for this. Don't store your passwords in plain text. Don't store credit card info in plain text. Don't store identification numbers in plain text. Just don't do it. There's probably an exception to the rule, and if you have it, let me know, but just don't do it. Hashes. So here's the interesting thing. I said before it's 40 or 41 characters. We have this password here. This password hash on the top actually means password. Does anyone know what this one on the bottom means? I can tell you. I have to do some web searching, but I can tell you.
My hex is...
Your hex is not so good. Well, it's not a hex. I don't know if it's MD5 or SHA-1 or whatever, but what you can actually do is you can actually put it into Google. And you can search. Now, what comes up is this presentation. Because it's on the web, and I put it in there. But there are some hash tables out there.
There's some hash made famous.
Apparently, this one hash. I'm hoping this is going to be a rainbow table. So they must have taken down the rainbow table. There's usually
I tried to search many of the sites that we used to have on the presentations, and they have been taken down since.
Yeah, so what you get, oh here, hash.in. Yeah, I can't find, this used to be one of them. But basically what it would be is it would be a huge like text document that would have like a word. You know, that happens to be, I think, the hash for penguin, the word penguin. And I actually hacked that. I was running an application and I couldn't figure out what the password was. I'm like, let me just put this into Google, see what I get. And it was penguin, which I should have known because the username was penguin. So I should have at least tried that. It was probably some kind of like Linux application or whatever. But like when I saw it, I was like, of course, why did I even try that? I tried password in like 1, 2, 3, 4, 5 or something like that. And it never occurred to me to try penguin. But you know, it has, these would have the MD5, the MySQL password, the SHA-1, and the MD5 of the MD5. So if you're like, oh, I can be really clever and like encrypt the MD5 with the MD5, this actually showed up, and so you could see it. It was just a dictionary.
I may be hallucinating, but I was doing something between like a 5.0 database, 5.0 MySQL and 5.5, and I remember using Maria or regular MySQL. Did they change their hashing algorithm for the password function drastically? Because I tried hashing two similar, you know, select password blah on a 5.0 system, and then select password blah on a 5.5 system. I got two kind of different hash, two different, I mean, they were clearly not the same length, so they were.
Right. Was one a lot shorter because
Yes.
if it was it the 5.0 one?
Yeah.
It might have had old passwords turned on.
So when, the funny thing is on the 5.5 system, because I was like, well, this is really weird. Both, for the same password, both hashes, when I tried to log in, would work. I put it in. So does that mean that on my 5.5 one then, I have some backwards?
No. And what happens is when you create the user, you give it a password.
Yep.
And you say like, grant all to on start to Sheeri at localhost identified by Sheeri. That's going to be the password. It put that word Sheeri, that would put that password and hash that.
Yep.
Based on its own rule. So when you connect, right, it's going to hash it also. So all it has to make sure is that the hashes match, right? So if you hash it with a more secure algorithm and then connect, and that more secure algorithm is on, the hashes are going to match. So it can't be the same password, 2 hashes. I've actually had some things where certain applications connected with the old password. So if you turn old passwords off, that doesn't actually say don't connect with the old passwords. It just turns encryption for new ones to this more secure one.
Okay.
So I've actually had things where I've had databases that don't have old passwords on and have both the longer and the shorter passwords, and they both work.
Got it.
Like for different users.
Yeah, so it'll still accept connections and try hashing one to one of the pairs, but you'll no longer create the old ones in the less secure algorithm.
Right. So SQL injection, there's a URL here with a lot more details, but I'll give you just the basics of it. If you have something like, here's how you can authenticate, right? Select count from users where username equals $user and pass equals $pass. And the username and password is supplied by the user. And if the count is greater than 0, then log it, right? This is very primitive, and nobody would ever use this, hopefully. But it gets the point across, right? So let's say your password is hi quote or 1 equals 1. So what happens there is you get this select count star from users where username equals foo and pass equals, because you have quotes right here, hi or 1 equals 1. Then what happens is, okay, username foo, so if that exists, and pass equals hi or 1 equals 1. Well, pass equals hi probably isn't right, but 1 equals 1 is right, so you'll actually be able to get a count if there's a username foo. Very simple example. There's also this. Has everyone seen this XKCD? I'll give you a minute to read it. So yeah, I mean, Robert quote, parentheses, semicolon, drop table students, semicolon, dash, dash. Yeah, that could do things. Here's a real example. If you do curl dash dash head on reddit.com, this is what you get. Okay, we've got HTTP, 200 OK, that's fine. Content type, great. It sets a cookie, who cares? And the server is quote, semicolon, drop table server types. So there must be some kind of like bot that sniffs and puts it, like there's probably some program out there that you just download to like sniff all the websites in the world ever and get the, the server type, so it'll say server, if it's a Unix server, maybe what version it's running. So if you know what version of Linux it's running, you may be able to know what securities to get. And then date and connection. So, it's kind of interesting. This is actually real, you can do it now. It's been there for years, like 3 years at this point. Escaping user input. So let's talk a little bit about what you can do to help avoid SQL injection. Things to look for, semicolon.
What was the command line? Curl?
Curl, Reddit, curl dash head, www.reddit.com. So things to look for, semicolon, backslash, lowercase g, backslash capital G. Those 3 end statements. Quotes, the word union, so instead of putting a quote, if you union a query, then you'll end up getting the results of your query as well. Look for HTML encoding, null or char 0, varchar and blank, those can also be problematic. Now there are libraries to help you. I wouldn't recommend building your own SQL injection library because it's been done before. I'm sure every code has some kind of library for it. So just make sure you escape it save yourself time because it's just, in the future you're going to want to, I mean, even things like looking at an email address, right? An email address has a certain format. There's a spec, there's an RFC for it. But even if you don't follow the RFC, right? The RFC will say there's no underscores in host names, right? But you don't even have to care about that. All you know is, right, it has to be something at something dot something at the very least, right? Maybe there's more than one dot, you know. Maybe there's one letter in the username. Maybe there's 20. It doesn't matter, right? But you know that there at least has to be one at sign and one dot after the at sign. That's the minimum you have to do. So you can actually save yourself time later, right, and not have to flush the junk email addresses out of the system, at the very least by looking at those kinds of things. So, you know, escaping user helps you do that because you're already looking at the data. So, you know, while you're looking at it, you might as well say, well, is there an at sign in it? You know, you're already looking for a semicolon. Why not look for an at sign as well? Be careful about buffer overflows. That's why you have to worry about null characters and car 0. What character set are you using? That can also cause inadvertent overflows because if you have like an HTML form, it does it by character. So you might say, well, the form is 10 characters long. You put it into a MySQL database. Is it 10 bytes long or is it 30 bytes long or 40 bytes long if you're using UTF-8? Plenty of libraries for user input. You can also use prepared statements. Prepared statements do all this escaping for you. They do all of it. It's very secure and very good. Now there's a trade-off. The trade-off is performance. The prepared statement will be prepared by the client and then executed with the variables you give it, which seems like it's fine, great, you're caching or whatever, but in MySQL it's per session. And so a lot of times you're connecting, you run the session, you disconnect, and then you connect again, run it. It's not using the caching. In fact, you've actually just added work. Because instead of just running the query, you've done this overhead of preparing it when you're not really going to run it again. But if you want to know how to do prepared statements, this is how you do them. You put question marks, you prepare a statement from a string, and the string has question marks in it, and those question marks delineate where you're going to fill in. Very much like programming if you're printing a string and printf. So you use user variables and then you execute the statement using A and B, using those variables. So trusting get or post. So HTML basics, right? If you have something in your header that says, Sheeri.com $node equals 10, right, for my blog or something, it's trusting that node 10, that's actually a get variable. That's what it's called. And what happens is the HTML, the PHP will parse it and say, okay, that's a variable, node is 10. I could put node equals 100, I could put node equals semicolon quote drop database, I could put, I could put anything in there. And so the question is when you're writing an application, do you trust get? Post is similar to get, except it doesn't show up in the URL header. It's just something that is from the form before. So when do you trust it? Should you trust it on page 2 of your application, you should probably only trust it if it came from page 1. There's a lot of problems now with things like cross-site scripting and cross-site request forgery, that what they do is they send that information to page 2 directly. They have their own page 1, and they send it to your page 2. So now they've got some modicum of control because they know what they're sending. If they're doing stuff like, you have a bank application and you're taking a picture of a check to deposit or something, right? Imagine you can just go to that form that says, are you sure you want to deposit $500 to your account? And you can just say, instead of like, oh, here's this picture, and what I snapped was a picture of a $1,000 check, right? Send that to page 2, right? So all of the checking that you've done on page 1 doesn't matter. They have a different page 1. Cookies, even with valid session IDs, those can be spoofed. Now I'm saying this to get you extra paranoid. I'm not saying this because I'm saying you should never trust get, you should never trust post, you should never trust cookies, right? You have to have something. Security is always a trade-off, right? If you don't want security, then you turn off your laptop and you put it in a locked room and you never connect to the internet. So it's not a question of being secure. You're never secure. You're just more secure or less secure. I like to say in my presentations, it always gets laughed, that it's like talking about safe sex. You never have safe sex, you just have safer sex. The only safe sex is abstinence. Everything else, it's like you're just hedging your bets and taking different risks. With PHP, registered globals, you want to turn that off. What registered globals does is it turns post into get into post. Yeah, it turns get into post. So if you have registered globals on, That means you can put stuff in the URL bar, so you can say question mark node equals 10, and even if that's not really a get variable, it will be parsed as if it was, and it will be used. So that's usually a bad thing to have. I think most people who use PHP kind of know registry labels off. It's kind of like saying give a password to the root user in MySQL. It's something that, it's pretty basic, but I feel like I have to say it, just like I feel like I have to say things like, when you start up, users don't have passwords, so you have to give them passwords. Stored code. You can use stored code in MySQL, like stored procedures or functions or views or events. And the benefit of this is that there are certain things you can do in the database with permissions. So with a lot of the stored code, you can actually say, this stored code should be run as a certain user. Right? You can run this stored procedure, and even though you don't have permission to see this table, you could run this stored procedure that joins these two tables, and you can run it as the definer, not the invoker. Or you can run as the invoker. Views can give you control so that you can give someone permission to see the view, but not necessarily the underlying tables.
Will that work on the columns as well? If you don't give a person column or table privileges, but you write a view that shows that you give the person.
No, they have to have. So the question is, if you give them permission to a view but not the underlying table, will they be able to see it? The answer is no. They still have to have permission to see the underlying columns, but at least you can give the developer something like they can do a select star from a view, right? Where it pretends like it's a table even though it's not. If you gave them a view that they didn't have permission to the underlying tables, then just let star from view, they'd get permission denied.
I'm coming from the other side of the relational database world, you know, the ones that deal with O and D and S.
Oracle, DB2, and SQL Server?
Yeah, thank you for remembering DB2. We're both getting on. But I forget, the last time I touched Oracle was, you know, Oracle 10.LML. And the restriction on, the ability to restrict access by column in your grants was fairly new then. And we ran into a big row of problems. I was working with a software vendor, and what they did was they classified every program an API access, right? And said that any API access you're classified as this type of user, and you only get these grants, and they tossed in a couple column restrictions.
Okay.
And the APIs were locked.
Right.
Because they thought their new tool was cool. And what we wanted to do, and I never got Oracle to do it, we just had to change classification of user, was you'd say these column grant restrictions only apply if user and not equal any API. Or, you know,
Right, so all the API users should be able to have it, but nobody who wasn't an API.
Right, and is that in?
Yeah, so every single permission in MySQL is per user.
Rockwell?
So I mean, you would have to do it with like some kind of a query where you would say, well, update the user table, set the permission equal to this, where user like API percent.
Oh, sure.
But you could do that. And I'm glad you brought that up, because basically what we're talking about when talking about stored procedures, views, and events, is we're talking about basically creating an API. Right? So instead of giving people access, direct access, and saying you have to write your own code to do this, or you have to write your own query, what you're saying is I'm giving you this hook into it to say if you want the user, you know, run this query and I'll give you the username, but it's really a stored procedure. Just call a stored procedure that gets it to you. One of the things about events instead of cron is that if you have something that you need to run every 5 minutes or every day, and it's pure SQL, you can run it from inside the database. So if it's pure SQL with some case statements and some logic and flow control, you can actually do that as a MySQL event. So, for example, back when I was at the dating site, we would have a little thing that said how many people were online, like how many users were online right now. Because if you logged on, and if you went to, not even logged on, if you went to the website and you're like, there's 10,000 people online right now that I could be matched up with, that's great. For a while, what we did was we just would select count star from the sessions table. When you have 10,000 people online and every single page has, you know, X users online, that gets old really quickly. So what we ended up doing was making what we called a caching table. So every 5 minutes, we would say select count star from sessions, we put it in that table, and then, you know, it would change fast enough for people to, you know, notice that numbers were increasing or decreasing. but it wouldn't kill our servers because every page load had this on it. And so what we actually did was we put it in cron, and when you put it in cron, you have to put the authentication information in there. So we had to say, MySQL-u user-p password, insert into, session cache, select account star from sessions. We can turn it into an event, then it's inside the database, and you don't need the authentication information because it runs inside the database. So again, do you need to store the password in cron? No, not if you use an event. Auditing and monitoring. So we've talked a lot about prevention. We've talked a lot about ways that you can prevent people from accessing or make sure they can't see information or meaningful information. But it's only one part of security is prevention. You can also, you also need to audit and monitor it because again, just because you lock your car doors doesn't mean your car is going to get broken into or stolen. You can always break a window in a car. So there's always a way to get into a system. So you can audit. So MySQL actually has an auditing plugin. Oracle, has an auditing plugin. I think they have auditing as part of like their enterprise that you buy. But McAfee actually has a free plugin for the MySQL audit. I haven't tested it, but it's on GitHub. So it's open, it's free, it's out there. You also want to maybe somehow have some monitoring or something happen. There are companies out there that have like database appliances that will page you if something is off, and there are certain monitors you can have. MySQL enterprise stuff has I think security monitors, like if you have too many people with a root user, things like that. How else can you audit? You can actually turn on the general log in MySQL to actually see all the login attempts. And I say the general log because the general log, basically, when you send anything to MySQL, whether it's a login attempt or a query or anything like that, when you have the general log on, that gets logged, and then the rest of the query runs or whatever. That's the first thing that happens is it gets logged. So when you're talking about something like the slow query log, that only logs things after they're done. The binary log only logs things after they're done. Because if something gets rolled back, it won't get put in the binary log. If something gets in the slow query log, it needs to know how slow it was. How long did it take? Well, you only know how long it took after it's done. So, by kind of the way they're supposed to work, the binary log and slow query log can't do things like putting a bad login attempt in. You can't see every query because if there's an error, it's not going to be logged. With a general log, you see everything. So you can actually do this, and I've done this, like when I'm like, can we delete these like 4 users? I'll turn the general log on for like a day or a week. And I do see maybe like a 1 to 2% performance decrease, but usually on most systems, 1 to 2% is totally handleable.
But is that a big-ass report?
It is a big-ass report. It is a big file. What I would end up doing in that case, like if I turned it on for 24 hours, I would also run a script that every hour move the log aside and flush the log, and then compress the log, because otherwise you get like hundreds of gigabytes of logs. But you can actually see all the login attempts, even if they weren't successful. So that's really good to answer the question, can I delete this user?
Sure.
Right? If they haven't logged in a week, maybe you can probably delete them, right? You can also lock out accounts with max connect errors. So you can actually say, if max connect errors by default is 10, and what that means is if you try to log in 10 times in a row and don't authenticate properly, you'll be locked out. Now, there's one problem with this, well, a couple problems. One of the biggest problems is it's not actually just 10 times in a row, it's 10 times in a row in a short period of time. And some people have actually tried to go digging for how long it is in like the source code and haven't found it. So I'm sure it's in the source code, but I haven't tried to dig it because I don't read code.
Deliberately.
Yeah, well, I think it's convoluted. So, I mean, it's in a short period of time. So it's not like if you log in today and then you log in tomorrow and after 10 days you'll be locked out. But it actually is pretty helpful for that. And it's funny because 10 you might think seems really low, but because of that that compressed time frame, I've only run into it like when I've changed the monitoring user, keep trying to reconnect or change the password to the monitoring user. So the other problems with that is that it's global. So you can't just say Sheeri can log in 10 times, but Jerry can only log in 3 times, right? It's 10 for everyone, it's 100 for everyone, it's 3 for everyone. Whatever you set it for, it's that for everything. The other thing is,
Isn't that a little dangerous though that somebody could you know, if you have a very unsecured like report user, and then you had like your web application that hits that site, and somebody decides they want to try to connect as the web app user, and they make X amount of connections.
Right, and
it
then
locks the account, and then your
Well, and
web
again,
app can no longer hit the.
that's a good point as to why you shouldn't allow just anyone to access it, even if you're like, well, they don't have usernames and passwords. They would have to do it very fast, though. Like they would have to use an automated tool to do that. But yes, they could do that. So if you ever get this problem, you'll see a problem that says something like Max Connect errors reached. And it's, from what I remember, it's a very obvious thing. And when you go Google searching for Max Connect errors, you'll probably find the blog post I did on it, which basically to unlock things, you do a flush hosts. That's how you do it. Now the other problem with that is that the flush host is global. So let's say both Jerry and I have locked ourselves out of our accounts, but you can't just unlock Jerry and I. There are ways around it. You can hack it, like you can like unlock Jerry by dropping his user and then adding it again. But that's really a hack. So it is kind of neat to have this, but it's not really flexible. So play hard to get, right? Don't store it if you don't need it. Don't store plain text passwords. Use MySQL events instead of a cron if you can, because if you don't store it, it can't be stolen, right? If you don't know my password, right? Like I know my husband's PIN for his ATM, and I don't like that I know it, but I do because he just types it on his thing, and I know what it is. And like I'm always like covering my PIN, and I'm like, it's just a thing, like. It's a joint bank account, so it doesn't really matter. It's not like he's going to steal my money or anything. I'm not going to steal his money. It's all the same bank account. But it's just one of these things that, like, if he doesn't know my PIN, he can't, I don't know, nobody can torture him and get it out of him. I don't know. And then I was talking about the auditing plugin, but there's also an authentication plugin. So there's been an authentication plugin since December 2010. And what that is that you use some kind of other program instead of MySQL's ACLs. Now, that's a general view. You actually technically are still using MySQL's ACL. You're just saying that this other user, maybe it's an LDAP user because it's PAM authentication, maybe it's a Windows authentication. Basically what you're saying is, oh, the Windows user Sheeri should just be like the MySQL user root. Right? You're basically saying that that's a proxy to it, and that's actually the language used, it's a proxy to it. There are some limitations. It's a one-to-one thing, so you can't say Sheeri should be root and Greg should be root. You would have to make two different MySQL users. It's a one-to-one corresponding thing, which is kind of annoying. It'd be nice if it was actually kind of able to do roles that way. So that's kind of neat, the authentication plugin as well. So you do things like LDAP authentication, you can do things like Windows authentication. And so I'm just going to end on this. I think this is my last slide. I don't remember. It's been a while since I've done this presentation. Create your policies, because there will be exceptions, but it's a good idea to still have them. Right? The policy, when I've gotten into policy discussion with people, and we're talking about things like, oh, all web page changes have to be reviewed or whatever, and they're like, but what if this thing happened 5 years ago, and the front page was vandalized, we had to change it right away. And I'm like, well, emergencies are different, right? And the whole point is that you agree on a policy. It's like a budget. You agree on it, and that's how you're going to do it, until such point as you say, okay, this one won't follow that. But that you already have big wigs in the office that say that, right? What you don't want is you don't want someone coming to you and say, why did you do it this way? You just made it really, unsecure, and now we lost all our data and you're fired, right? If you have a policy to do it, then, they might say, well, that's a stupid policy, but at least you were following it. But everybody agreed to the policy beforehand. So it's still a good idea to have them, even though, it's not the greatest thing in the world. And yeah, that was my last slide. So I'll leave that there. And does anyone have any questions or comments or feedback on MySQL security?
Well done.
Thank you.